go. Okay. Hello, everyone. Glad you're all here for this session. I hope you had a good first part of the conference. My name is Alex Stinson. I was here last year. I'm not sure.
Sfruttando le informazioni che contiene nel suo modello. Ma è
People, okay, good. So happy to be back. I do feel pretty okay. I'm excited. So hope to bring a lot of the enthusiasm to you. This is a session on health monitoring and health instrumentation in your applications, and we'll go through a couple of things to get you up to speed on that. I'm from the Netherlands. I work for a company called Xebia, and we help customers move to the cloud. But usually they have complex systems, and they are distributed. So any of you that's building modular monoliths or those kind of things, yes, okay, that's still good. Distributed systems where you have microservices, things spread around. A few people, okay, good. Well, anyway, whether it's the systems get more complex, and if you run them in production, it gets more and more challenging to keep them all running because there's so many moving parts, and sometimes it just stops working. You get a call from a customer like your website is down. They're like, oh, something must be wrong in the back end, but where is it? And you start looking at logs or something. I'm not sure how you do it. Maybe you have some monitoring tools, but it is challenging to see how things work and how things flow. So getting to know how your system is behaving and what things are doing well and which ones are not so much, that's kind of a challenge. Well, and there's already a lot of work done here. There's looking at the performance, so not necessarily how fast can we do things, but how are we doing? That's also performance. We have a lot of things that are already there, and we have application performance monitoring tooling, APM tooling. I put a few of them up there, so you can choose whichever one you want, but it's usually good to use some tooling that's already out there to get a grip and a view of your entire system. So this is where we start talking about application instrumentation. Now, the gray box is your application and all of its parts. And let me just get a clicker here, that would be easier. So the usual signals that people have for instrumentation are logging, tracing, and metrics. Who's doing the last two? Because that's kind of an interesting one. Most people do logging, but who's also doing tracing and metrics? A few people. All right. Well, again, there's a lot of things happening in that space as well, because you can build those parts of instrumentation. They're called the pillars of observability, because with those things, the logging, tracing, metrics, you can look into your system at more detailed levels. Logging is about what happened and you store it for a long time. Tracing is more about the flow of your application, moving from one service to the other, touching databases, caches, whatever. And you want to see how did we move about, so that's usually only looked at when it's necessary. And then you have the metrics, which is more of a number information. And you collect, you output that information from your system, so, and you collect it. Do look at open telemetry, because that's the predominant thing that is doing a lot of work on those three signals, as they call it. And they have a lot of libraries and a lot of tooling and a standard, so it's a good thing to look at. And then you start collecting that information, you monitor it, and you have a lot of tooling on the other side that you can use, analyze what's going on, alerts, and doing dashboards with gauges and dials and red and green lights. So that's kind of what you do with the application instrumentation, and that's a good thing. So if you're here, good for you. Keep doing this. But there's one side to this, and let me tell you a little story of going to the doctor. Because if you go to the doctor, how you typically go to a doctor is that the doctor will ask you, or you will ask the doctor, am I sick? Maybe I don't feel so well, but am I sick? And the doctor will say, okay, let me measure stuff. So that's what we just did, right? From the outside, we looked at the system, and the system, your blood pressure, your heart rate, your respiration, you can measure things from outside of someone's body, and then you can make an educated guess on how that person is doing. So in this case, pulse 60 and a good blood pressure. So usually the conclusion will be you're doing fine. This is good. And then you say thanks. But it could also be that these are the signals. So what do you think now? Are we doing okay? If we see, a pulse of 180, and so that might be my pulse rate right now, right? But so you could think that this is not okay, but that's not so good. So you maybe say, okay, thanks, but no thanks. But this is from observing from the outside. But how can we make educated insights from those numbers? Because, you should ask the patient itself, right? So that's usually what happens. But anyway, so there's a lot of challenges there because you need to combine multiple things, you need to know about, and you need to have intricate knowledge of the system outputting those numbers. And usually it's the ones building those systems, the applications, that know best when the system is not doing as well. So it might be, I'll give an example, if something is put on the queue or it's taking things from a queue and the queue size is stacking up, it's usually like, we're not keeping up. So we're still doing okay, but the fact that we get more and more in the queue, just the lines, with the ticket office are getting longer and longer, at some point they would say, this is not going in the right direction, so we need to do something. And usually the things on the inside are not known. We can measure blood pressure, some other things, but like pain levels or so, that's quite difficult. So in modern medicine, it flips around. And this is essential to the health monitoring, because otherwise it's just what we did before. So now the doctor asks you, how are you doing? And then you say, well, the same numbers as just, and we could say, this is what we could say, but maybe we will say this. It's okay. I'm running, so I'm exercising, and this is typical for me. So this is not too bad. If it would be 220 for the heart rate, that's probably not such a good thing unless you're doing a short sprint. Can't do it for very long. But this is where you would say, I'm healthy because I know, and things like other signals, like my back hurts, they're not present, so I'm fine. And that's essential. So people building the systems know when the system is doing well, not just based on the numbers, but they know how to interpret the numbers. And that's what you will be doing if you start building health endpoints, health information from your system. So it all depends, right? You do it yourself, you self-assess, and context matters. It's from the situation, the circumstances that you're under, you could take all of those things into account. And even the unmeasurable things that are not measurable from the outside, like how many things are in an internal list, for example, or maybe from circuit breakers. If you use the circuit breaker pattern, you can look into the circuit breakers and what state they are in. That's something that can't be measured because it's internal in-memory state. And you can look at how much memory are we using, but have the circuit breakers, tripped, like something went bad and all of them tripped too fast over the past hour, that could be also an indication. All right, that one is enthusiastic, see, that's already there. But the metrics are the numbers, so you express them in numbers and you can observe the numbers. You can see the trends. The graphs would typically be used for visualizing metrics. But it's the estimation of the health, the little thermometer that's in the green, that's done on the outside. And what we just talked about is the health information is done from the inside. So your application itself is outputting that information. And now if you're into DevOps, so you build it and you also keep it running in production, that's like a really nice thing because you build those health checks into your application and you're also observing them. And if you deploy a new version of your application, you will deploy the new logic for the health checks. Because if you start using some cache, for example, that you depend on, you could build that into your application. Is the cache there? Is it doing okay? Because maybe we can look into the cache from the outside because it's a dependency. And we can say, okay, we can use the cache or we can't use the cache because it's unavailable. We're doing a fallback. So we're not doing really well. And that puts us at the picture again that we had, but now we can build health information. But that's something additional that you need to do. And OpenTelemetry doesn't really cater for that because health information is usually output as an HTTP endpoint. You can think of other ways, but this is the most common one because it's easily observable. And then you can start monitoring from the health. You can monitor the health endpoint, so look into that from the outside, and that's where you get all the information from the inside. How is this thing doing? And there's even a thing, and I'll show that later on, where you can output health as metrics. Because if you say, I'm good, I'm not so good, I'm not doing well, you can add a number to that level and then output that as a metric information. And you can build a graph of it. Simple graph because it only has a few values, but you can see trends and averages. Now, if you start thinking about what can we do with health information, I already gave an example on circuit breakers, for example, but you can start simple, right? The simplest things are, is the thing even running? So by outputting a health endpoint saying, I'm alive, is already a thing that you can observe from the outside, which is kind of nice. The status code can be helpful in saying, how well are you? You know, are you like thumbs up, 2 thumbs up, or like in the middle? But also the latency, the time to respond might also be an indication. So you can already do quite a few things, even if it's simple. Internals like memory and disk space, most tooling do that at, for example, a Kubernetes cluster level. How are each of the nodes doing? That's the hardware. But you can also do that from inside of your own application. And there's already a lot of instrumentation inside a .NET application. You should have a look if you didn't before. But if you do, what is it again? .NET metrics, you know, .NET, the command from the command line, metrics, and then start observing an application, you can see that they're already outputting like how many garbage collections do we do, how many memory pressure do we have, heap sizes, all those things are already in there. And you can look at them. But you can also add your own stuff. But the internals and disk space and those kind of things, they are easily and simple. Then you can say, okay, but it's not just me. I also am dependent on other things, like a database, or maybe I do a call to a different thing. And then, you know, you can say, I have this external lookup from a web API that looks up zip codes and translates it to a physical address or something. That could also work. And excuse me, the other one, readiness and liveliness, that's where you can look at a system. Is it ready to take on a load, and is it still alive? So it's kind of like, are we available? But liveness is like a different thing, and we'll get back to that with clusters later on. And then finally, taking it even a step further, is you start observing your health and predicting things. Because if you, especially with machine learning and AI, you can kind of predict when things go bad. Because usually before a breakdown of a system, we see this trend in memory pressure, for example, or in queue sizes that go up. And then you can be even proactive in taking countermeasures, maybe stopping some things or doing fallbacks or scaling up, scaling out. And the one that I also like is the certificates. Because a lot of systems go down because the certificates expire when you least expected it, like we didn't expect it. So with an expiring certificate, you can predict that. So if you look into your certificate store, or you know the names of the certificates that you as an application or a service are using, then you can just look into the store and say, okay, this one will expire next month. You know, we need to do something. Not now, but soon, because otherwise it will go bad. And that brings us to this thing. So health is usually expressed as being, okay, green, healthy. And if you take an HTTP status code, it's usually 200 okay. Then you have unhealthy. It's indicated with a 503. It is available, but it's just saying we're not doing well. But this says, okay, red. No, this is not a good thing. It's a real error code. And you have something in the middle, which is called degraded, which is, well, we're not doing really good, but we're not failing either. So it's somewhere in between, like the failing certificates. In a month, so we are degraded now. Or maybe the pressure on the queue sizes is going up, degraded, so maybe we need to do something. So that's kind of an in-between state, so no black or white. Now, if you want to build this into your application, you can already since .NET Core 2.2, so it's been there for a while. It's pretty stable at the moment. So what you see here is like a spans from 2.2 to 8.0. There's a couple of NuGet packages that you can use. Some of these are inside of the .NET framework. So if you have the core effects of .NET 6, 7, or 8, some of those are already in there. Like the one for Entity Framework, I believe you have to add that yourself because it's an opt-in. Not everybody uses Entity Framework. And then you need to bootstrap that into your application. So in your ASP.NET Core application, you need to host, host something. So typically it's an ASP.NET Core application, but it doesn't have to be. It can be a standard background worker process as well. But you will need some middleware if you have some endpoint that you can query. You might already have something. And then you have the implementation in the dark blue for your application. So this part here. This is where all your controllers. Oh, yes, this is a touchscreen. That's where your logic lives, and that gets executed when the middleware dispatches it and routes it to the controller or whatever. With the dependency injection system, builder.services, this is the new way. If you do it with the startup CS still, that's also fine. But you will do, you will use the services variable there that you get, the iService collection. And you just say the simplest version, add health checks. That's enough to wire a simple standard health check service that will be registered. And that will do as much as create a single endpoint. If you map a new endpoint, for example, /health, that's done with map health checks, and you pick the name of your endpoint. So you need to have that as well, because otherwise you can't get the information out of the system. So this is it, and this will give you a /health, and if you visit it, it will give you the healthy, degraded, unhealthy text with the status codes. That's as simple as it gets, but this is only where it starts, right? All right, so how do you use them? The health checks, because each health check checks a particular thing. And you can implement those with a interface called iHealthCheck. It has just a simple method, an asynchronous method for check health. And it gives you a bit of context, which is things that have been registered, and a cancellation token, because you can stop it if it's a longer lasting operation. Now, one of the best practices, health checks shouldn't take long, because you don't want checking your health to cause that you are not healthy. And that's sometimes what's happening, right? If you do a lot of outbound things like checking things on the outside, it might just take a while for responses to come back, and all the time you're not responding. So other systems might think, ooh, even the health points are not responsive, so that's not a good sign. But so don't make them too complex. You evaluate the health points whenever it's necessary by when a call to that endpoint comes in. That's one way of doing it. But you can also flip that around and output it or by yourself, publish it periodically. So that's usually a minute or so, but you can tweak the time interval and send it out. And how do they do it? Well, we'll get into that in a moment, but it's just a matter of iterating over all the health checks that you have. Typically, you don't have one, but multiple. And this is from the actual source code. I thought it was nice when I looked into it. It says game over, man, game over. Anyone know the reference that I think it is? No, Aliens, the movie. Game over, man, game over. Yeah. But this says, okay, so if any of the health checks fails, we just say, we're unhealthy. So we don't even have to continue. This is just that we know that the overall outcome is failed. So we're unhealthy, but we will still continue to give you a full result of all the health checks that will be performed. Now this is how that goes. So this is back what we saw earlier. If you do add health checks, you get a default health check service. Then you need to do the map health checks because you need the endpoint. And then you start registering health checks. If you want to do more than just have a availability endpoint, that's where we were so far. So you can do synchronous Lambda expressions, just add them ad hoc. You can do asynchronous, slightly better, for throughput and performance. So you can do whatever you want to do there in this Lambda expression. But what you typically see is that you implement this health check, the interface we saw, and use that class as a generic where you say a check of T, where T is your health check. So it could be a SQL connection that does usually they do a select 1 equals 1, and they see if they can at least connect to the service, in this case a SQL server, and get a response, and that's fine. And then you can do other things like URL health check. Is the external URL reachable? And then you have a set of health checks registered. Now, whenever a call comes in, a GET on the endpoint, they start building up this health report. It's literally called a health report internally. And they will start iterating over each of those health checks. So they check the first one, and that stays in the green. So there's an entry here, a health report entry, that is also green, and the overall state is still green. Then we check the next one, that's also fine, and then we do the database, but the database, depending on how it's implemented, might respond slowly, and slowly might not be a good thing. So the thing reports degraded, we should be faster. So all right? So the health report also has this state now of degraded because one of the health checks turned out to be that way. And if you try to reach the external URL and it turns out it's unreachable or not reachable fast enough, you might have a timeout to not wait for too long, then you can say, all right, the health check failed. So the health report says we're unhealthy, and this is what we found doing all the checks. So we get back a 500 something. You can tweak all the status codes, and sometimes you need to, because some of these things don't respond well. For example, if you look at the outside at a health points, some monitoring tools say 500, that's not okay. I can't accept this because it's an error. So you need to pick a different status code that says we're 200 okay, but the information says we're unhealthy. So remember that it's not always 500. You might need to change that. All right. Let me quickly check the time. What time did we start? Okay, just you keep track of time, right? So, all right. Yes. So I'm going to open up the program CS. Is this visible in the back, or does it need to be a little bit bigger? Yeah? Oh, bigger, you said? Bigger. Okay, we can do that. Better? Okay, otherwise, I'll work with it. Okay, so what we have is a simple project. It's I usually pick retro gaming for a theme, but this is a very simple one. So we have the source code here, and the things we need to focus on is programs, yes, some of the settings, and we'll look at a few controllers. There's only one, and it's very buggy, and some health checks that are as examples. I'll share the link to all the source codes. It's on GitHub. So if you go to github/AlexTisse, you'll find this one there. It's called health monitoring. That's the URL essentially. All right, so let's have a look at this one here, and we'll put a breakpoint, and we'll do a little bit of stepping through, and I'll just run this from Visual Studio Code. It's a .NET 8 project, so it's fairly recent, and if all goes well, we should be seeing. Let's get rid of this for now. So we do the new startup, the simplified startup. This is not minimal web API, but so we have the web application builder, and we start registering some singletons. These are the single instances of our health checks. That's a best practice that Microsoft recommends. Their implementations are thread safe. If you do the same, that's fine. You can have share state because it's a singleton, and you know that. So it's only sometimes you need an interlock increment for something if you want to increase something because of multi-threading and concurrency. But this is a good thing. Okay, so we do all these registrations. Then we have the thing that we said, okay, well, let's do the add health checks. And you get back a health checks builder implementation. And with that, you can add all of these health checks. Now, there's a couple of things in here. We'll look at this later, these two publishers. That's for later. But here you can see that you have something like the allocated memory. that's being added as a check. And here are some examples, like the forced health check, where you can just force it to be something. This is a demo, right? So we sometimes need to force it to be unhealthy. We have a sample one that's a slow dependency that takes a little while, that goes from, I'm not healthy to I'm healthy now after 5 seconds. And just to take that as an example, it starts with a task delay, and when it completes, then before it completes, it says dependency still initializing. But if it's the task has completed, then it will say, I return a health check healthy, and the dependency is ready. So that's something to mimic a system that is slow to start. And you have those sometimes. If you immediately put load on it, then it will just crash because it needs to pre-fetch data from something like a build-up internal caches or the pre-calculations. And if you hit it too soon, it will just go down. And it comes up, and you hit it again, and it goes down. So this is where for later, this is something that is very useful for the readiness checks that we talked about, readiness and liveness. All right. So let's get back to the program CS. All right. Now I also add this health checks UI, and we'll get to that in a second. But this is only for development purposes. So we will add like an internal dashboard that can show all the health information, and then the rest of it is just a bit of mapping. But we map this ping and pong and a health endpoint. All right, so these are normal endpoints, ping and pong. Health, it does something weird with the response writer. I'm just highlighting some things, and I'll get back to them in the slides. But if we just continue this, then a website open up, and this is probably what you know, right? It's just outputting two values. It's not what we want to look at. But if we go to the ping, that's the endpoint, it says healthy. This is the one you get, but we didn't name it /health, but just ping. And we can do the pong as well. That's also healthy. And we have this health. That was the other one. That's not what I wanted to show. I'll do localhost 5003 /health. This is the third one that I showed, where I said the response writer. This is where we say we want to write it differently, because we have all the information of the health checks, except we don't expose it usually, because that's like a security risk. Hackers or people that want to do a denial of service attack will find it very interesting to see this information. Like, okay, let's try this, and ooh, this is going bad. So we're on a roll. That's not what you want to do in production, but this is development, and we're checking the development environment name as the where we are currently running. But this is all the rich information that is there. So you see that the process allocated memory, for example, this is how much memory we are using for now. We see that the dependency is ready now. We might, just for demo purposes, oh no, I'll do it differently. I'll stop this, see what happens to my browser. Okay, I'll start it again. And it hits the breakpoint if all goes well. I might just get rid of the breakpoint for now. There we go. Okay, and I'll show you this dashboard here. See this thing? This is I'll explain what this is in a moment, but this is all the checks that we just had. The allocated memory, this one is unhealthy. It takes 5 seconds, and it periodically checks, and now all of a sudden, no, we're ready. So this thing is ready. You see that there's a tag here that's ready. That's something that I chose. So to make a distinction, what do I want to check first and what do I want to check later? So this is something that I might want to check. Are you ready? This one is important. The other ones maybe not so much. But that's your design decision. That you know which ones matter at the beginning and which ones matter when we're fully functional and operational. All right. So getting back to what we just saw, I already mentioned that that there's only one thing for Entity Framework Core that's out of the box, where you can do the DB context that has a connection string underneath, so you don't have to specify the connection string. That's nice and easy to check. But you can also build your own. And if you make them reusable, like in a class implementing iHealth check, that's a good thing. You can put it in a NuGet package, and you can do it across your teams in your organization, or share them in the community. And there's a lot of community packages there, and they start with ASP.NET Core, and they're from this Xabaril. I believe they're Spanish. I'm not really sure. But they build this community around a lot of implementations of those health checks, which is really nice. And you can pick this is not a complete list, but you should look at those, because probably the thing you're using is there. They also build publishers, and they build the dashboard that we just saw with the health checks. So that's also very pluggable. It just takes one line of code. You can customize it, because you saw there was a nice .NET Foundation thing. This is a sample that they give with the nice colors, but you can tweak this reasonably in its look and feel. All right, so what did we talk about so far? Multiple endpoints. That's when you get a bit more distinctive. We saw the ping and the pong and the health, but there's also the, that's a bit too soon. We'll get back to that. But you can do readiness and liveness checks as well. Yeah, the singletons, we talked about that. Visualizing, this is the health checks UI that you can run, as we saw, in process in your own service, but only do that from a development scenario. But you can also run it from a container or externally. So if you want to host it yourself, you can, but you can also spin up a container. Now let's look at a bit more advanced health checks, because you know, this is where things get really interesting. Yes, I'll do the demo in a bit and cover this quickly. If you want to be more, no, we should do demos. We should do demos. Sorry for that. So I'll stop this. What I'll do now is I'll open up a terminal session. I'll get rid of this first. All right, and I will do Docker Compose up with the build. So this will start building a container for the web API, but it does more, because it's a Docker Compose. So we have a Docker Compose file. And in the Compose file, we have quite a few things. So at the very top, we have the web API with the Docker file that's being built at this moment. We have the health checks UI. That's the thing we just saw, but just then as a container. And it's pointing to this web API at this port 8080, and with a endpoint for ready and lively. That's the two health checks that we, endpoints that we register for this health checks UI. We can view it from the outside on port 5000. We add Prometheus, which is a metrics collector. We have a mail thing for when things go bad, we'll get reported. Show it in a bit. We have Seek, which is a logging thing, but you know, we can output health information to a log as well. And we have Grafana for visualizing what's in Prometheus, because that's the time series database, but Grafana does all the dashboarding, and it has like this that's always being sent from this address at this port 1025, but it also the mail itself can also be viewed at this 1080. So that's just a few ports that we will look into. So what happened now is, let me just close the other tabs. This one is no longer working, but because that's the old one. But now we have a similar endpoint here. That's the container running now. But we could also look at the thing that's now looking from the outside to port 8080, where the two endpoints live. We had the readiness check and we had the liveness check. And I'll just decrease it a little bit. So you see that everything is in the green now. But now we'll start messing with the system, because demos. So we hit this endpoint, and inside of the code you can see that we trip a health check to go from healthy to degraded. Now here we already see that it picked up on that, and we can go even one more. So if we do that again, like so, it's now unhealthy. Oh, it's fast now. It depends on every 10 seconds, so we were just in time for the next check. But now we're no longer good. So the liveness is like, no, bad. So now we go to Prometheus. And in Prometheus, we can say, okay, I want to look at these things, the health check information. That's a metric that's being output. What we did by adding this, you can add a Prometheus publisher that will do the health to metrics. The little arrow that I talked about, you can output your health information as metrics. And if we take, do an execute on this and take a graph and do it for just, no, that's not what I wanted. I wanted to do minus here, like so. You can see where I just tripped it. See, it's going to 1, and then I did again, and it went to 0. And now I hope that the Grafana is also there. Let's see, is it still? It does have the health checks. It takes a bit, so we'll do it the last 5 minutes. You will see the same information there, right? So we have multiple things. We have the slow dependency that's there. This is allocated. This is forcible, but this is the tripwire, the one that we tricked, going from to 1, that's in the middle, this point here, and then all the way down. And I have configured an alert as well. So you can use Grafana for that to say, if this goes below 1, and you can pick any of the signals, you can do the various tags, or you can look at individual ones. But and it stays like that for a while. So don't have to immediately panic like, oh, we had because sometimes systems are self-restoring and like give it a bit. Oh yes, we're still good. Your heart also skips a beat once, right? We don't immediately go like resuscitate you. But this is an indicator for the alert. It's in the green now. So it's good, but we will come back later, and then it will be red with a broken heart, like, oh, it's not so healthy anymore. Okay, so you can do this at a frequency from various locations. If you have a geo-distributed application, you can do alerts. You need to think about, what is a signal that we are really bad? How long should things be? And what do we need to check for that? So you can use any of the application performance monitoring tools. This is Azure Monitor in Azure, but it's whatever you have or want to use. We talked about the publishers a little bit. Publishers do a periodic check internally, so they will use the health check service. You add them, as we saw with Add Application Insights Publisher, the Add Seek, that's also one that you can use. And then you have these registered publishers. And whenever the time comes up that you configure, you will have this health check publisher hosted service that will call the default health check as if it was being called from the outside. And it will build up the health report again and then publish it through this resolving of the innumerable health check publisher implementations. And we'll call each of those and say, okay, publish this for me, please. And it will do so to App Insights or Seek or whatever I believe Datadog is also there. Prometheus used to be there. It's still available with a push gateway, so an intermediate, because normally Prometheus scrapes, and it can scrape from a gateway, a push gateway, where things are stored temporarily, but you now can just output metrics information from your application. We looked a little bit at that. Maybe so it might not go red now. I'm not sure. We'll have a look. I need to think about 1990. I believe it's health metrics. This is the stuff that you output now from your application, which is health of metrics information that Prometheus understands. So this has all the information that Prometheus has been scraping. Yeah, and we can, at the last thing, because we had the publisher there, I'll show you the App Insights. So Application Insights, that has also been collecting information. And we need to go to the, let me see, where is it? Metrics. And I hope this spins up in a bit. So we have the custom metrics here, and we can see the status. We can do averages, but essentially the max for the last 30 minutes, apply. This is essentially how we can see the health information going up and down. Yes, we're out of time. I'll skip the other part. We looked at it already. So this is in the slides, will be shared. And I hope you saw that we were able to take your applications, put all this knowledge in there with endpoints, with implementation for the health checks, do it in a variety of ways. So not just for tooling, but also for outputting, like Prometheus. So you have the world in application performance monitoring, but now more knowledgeable because you put your knowledge of the system in your implementation with health checks. Whether it's containerized or not, that everything works. So do have a look at the source code. You see that we're protecting the 8080 endpoints, for example, because you don't want to expose those things, but from the cluster, it's reachable. And you see that in the Docker Compose as well. So do play around with the bits there. Thank you very much, and I'll be around for questions afterwards, but enjoy the rest of the day.